Hello, 13. A calculator problem. How exciting. Let f of x equal the cube root of x minus 4, and let g of x equal x squared plus 2. We want to find f of g of x and g of f of x, a composition of functions. This first one says start writing the f function. So f of g of x, we will start writing the f function. The f function starts with a cube root. But instead of writing x, we will write the entire g function, x squared plus 2. Once you're done writing the g function, continue writing the f function. The f has a minus 4, so we need a minus 4 there as well inside that square root. That's a little clunky. Let's write that as the cube root of x squared minus 2. That looks better. 2 minus 4 is minus 2. All right. Now let's go ahead and do g of f of x. G of f of x is a very similar thing, except g of f of x says, hey, do it the other way. Start writing the g function, but instead of x, write the entire f function. Well, the g function starts with an x, so instead of that x squared, we need the f function squared. So we need the cube root of x minus 4. We need that whole thing squared. And now we finish writing the g function plus 2. Now I'm going to write this as x minus 4 to the 2/3, because that's what this means. It means square it and cube root it. That's what the 2/3 power means. It means do both of those things. So you should know that this is the bird graph. So now part B says to find the two values where f of g of x equals g of f of x. When two things equal each other mathematically, what that means graphically is that they will intersect each other. So we want to know where these two graphs intersect each other. And when we say where, we typically mean what x value. Or maybe that would be better, like when do they intersect each other? I don't know. Either way, we need to graph these two functions. So enter your pink function as y1. You need to do a cube root. Two ways you could do that. You could either put that whole thing in parentheses, type x squared minus 2, close your parentheses, and then raise it to the power of 1/3, because a cube root is the power of 1/3. If you're on an old calculator, make sure you put that 1/3 in parentheses, otherwise it will not work. Or you could hit math button, math, and then 4, and that will give you a cube root, and then you could do your stuff. For g, you could do a cube root and put it in parentheses and square it and then add 2 to it. But honestly, dude, just like you gotta just become friends with the fractional exponents. So type y2 as parenthesis x minus 4 parenthesis, raise it to the power of 2/3. If you're on an old calculator, put the 2/3 power in parentheses, otherwise you will be sad, and graph it. When I don't know what something's going to look like definitively, I always start with a zoom 6. Zoom 6 will give you a standard 10 by 10 by 10 by 10 window. I'm burpy. I ate a hamburger and a really big thing of macaroni and cheese. Digestion is occurring. So zoom 6 gives you a standard window. When you do a zoom 6, you get something that looks like bloop, 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 and then like bloop, 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 something like that. You can't really see the intersection points very well, but you can tell that they do intersect at a certain spot. So if you don't then like zoom in on that intersection point, you're not going to see that there are in fact two intersection points. And there are. I told you there are. Find the two values where they intersect. So find those two values. To get a better view of that like intersection point, I would hit the zoom button. I would choose option 2, which is zoom in. I would move my cursor to the right to about the x value of 4. I would move it up to about the x value of 2.5, so that I'm right on that hot zone where it looks like they intersect, and then I would hit enter. When you do that, you get a much better picture of what's going on. You get something that looks more like whoop, and then whoop, whoop. It's much easier to see the intersection points that way. So now hit second Trace brings you to the calculate window. We want an intersection point. That's option 5. First curve, if you only have 2 graphs entered, for the first curve, just hit enter. It will automatically then jump you to the second curve, so hit enter again, and then hit enter a third time when it asks you to guess. It's going to take you to whatever intersection point you're closer to. It took me to this one. That's fine. One of those intersection points it's telling me is when x is 4.507. Round it to 3 decimal places. We'll find the other intersection point. So second, calculate, intersect. First curve, enter. Second curve, enter. Don't hit enter again for guess yet. Move your cursor to the left so you're closer to the other intersection point. Then hit enter, and it will tell you that x equals 3.815, and round it at 3. And there you have it, a composition of functions problem.